All right, we've seen enough concepts on IP version 6. It's now time to go through configuring, routing, and interoperating. That is, setting up IP version 6 on your Cisco router. It's actually not too bad. Routing using a new version of the OSPF routing protocol and some of the other routing protocols we'll see, but we'll set up OSPF in here. And interoperating strategies, which looks at how we can tie our IP version 4 networks to maybe a new IP version 6 internet or vice versa. Maybe run IP version 6 within our organization and still work with the current IP version 4 internet that is in existence today. Let's get going. Configuring IP version 6 addresses is a piece of cake. It's just like configuring IP version 4, you just have to type more. You can see that I have router 3 and router 4 configured with a basic WAN link and some Ethernet and serial interfaces. What I'm going to do is go through and show you how to set up IP version 6 addresses on each of those interfaces. I'm going to type out every single one just so you can get the feel of it. Then we'll come in and set up a routing protocol so we can have some basic network connectivity between the two Ethernet sides. So bring up my terminal. I'm sitting on router 3 right now. Do a quick show IP interface brief. And you can see that these still have IP version 4 addresses, just because this is the topology and the setup I've been using all along. The link to router 4 is the only one that I have lit up right now, and Ethernet 0, which is currently unassigned. So what I'm going to do is I'm going to get under interface serial 0/.4 right now, and let's give it an IP version 6 address, because you can have an interface assign both a version 4 and version 6 at the same time. It's called dual stack. So we've got 2001, 210, 10, colon 1, colon 6, I'm going to have to flip back and forth between this, but colon 1/64. So you can see the first 64 bits right here are the network ID, if you will. Then we have colon, a whole bunch of zeros, and the 1, which is going to be its host ID on top of there. So let's jump back over here, and I'm going to be flipping back and forth. The command is going to be IPv6 address, just like IP address, followed by, and you can see right up there, what address do you want to assign it. So I'm going to type in 2001, colon, 210, colon 10, colon, or wait, no, colon 1? Is that what I did? Yes, colon 1, colon 1. Wait a sec, is that right? Yes, that's right. So that's the address, and you can see documentation is going to be key until we get used to remembering these huge numbers. It's going to use the slash notation. You can see slash and then whatever you want the prefix to be, or you can have it go via DHCP, also known as autoconfig. Well, autoconfig slightly different, but similar concept. So I'll put /64, hit enter, IP address is assigned. Now IPv6 on some of the, depending on your iOS version, this command may or may not be there, may have to be enabled. So you can enable IPv6 processing on that interface. So I'll type that in as well. So at this point, I now have one address assigned. Let me go under interface Ethernet 0/0, do the same thing. We'll do enable IPv6 address, and the address is 1FE0, 1FE0, colon 1111, colon 1, I believe is what I've got. Yep, /16. Okay, so it's enabled, it's good to go. Now I'll jump back here on router 3 and do our familiar command, but with a slight tweak, show IPv6 interface brief, which is the just a modified version of show IP interface brief. You can see the output is just as good. We can see that our serial 0/4 right here has the address assigned to it, and look at this. Look at that. Phew, that's our link local address. FE80, remember I was talking about that? Colon 203 E3 FFFE. Remember, it squeezes that in. If you watched the last video, it squeezes that in the middle to make it full 64 bits. And then you have this as well, which is, if you remember, the MAC address. The MAC address of, or the generated MAC address of serial 0/0 is that, followed by that. And you can see that was directly borrowed from Ethernet 0/0. Since serial interfaces don't have MAC addresses, it just stole the one from Ethernet 0/0. It's got no problem having two of the same link local address, because it's really just per link, per segment. So it's not really a routable address anyway. Below here, you can see the IPv6 address that we assigned Ethernet 0/0. So let's at this point hop over to router 4. Now again, this router doesn't have much configuration other than the IPv4 addresses. So I'm going to go under serial 0/0.3, which is the interface used to reach router 3. And I'm going to assign this IP address, and then I'll do the same for the Ethernet side. And then we'll do a ping to see if we can check connectivity. So 2001, 210.10.1:2, which is the second IP address of that subnet. Let's hop back over there. I'll jump in here, IPv6 address, 2001. So it's a public address, if you will, 210.10.1:2/64. IPv6 enable. Go under my interface Ethernet 0, do IPv6 address, and that one was 1FE02222. 1FE0:2222:1, I believe, right? Right. /16. Sorry for the flashing screen flickers there. Just looking at my addresses. So at this point, we now have addresses assigned to both sides. I'll do a show IP v6 interface brief. Got to get used to that v6 on the end of everything. And you can see there's my Ethernet address with its new MAC address as its link local. There's the one that we assigned. We've got serial 0/0.3 with our address that we assigned. Let's do a ping. We're going to type in ping followed by, and you type in the protocol, IPv6 in this case, and then I will type in the IP address of the other side, which copy and paste is your friend, 2001:210.10.1:1. We are 2, and router 3 is the 1, so I'll try that. Hit enter. Phew, look at that. It's just like the days of old with IP version 4, the old days. You remember those when we were running IP version 4? 5 responses, just as fast as always, but now using an IP version 6 address to ping. Now let's check our routing table. Show IPv6 route. It's the same old commands we've always been used to using, but now with a v6 appended to every IP that you have. And you can see there's our routing table. You can see the connected interfaces right here. These are the local ones, or essentially the link local addresses that are generated, even some for null 0 down there. But as of right now, we're not learning about any OSPF routes or RIP routes or anything else like that because we have no routing protocol running. So at this point, router 3 and router 4 cannot ping the opposing Ethernet sides because it hasn't learned about them. Let's fix that. In order to do that, we have to take a view into the IPv6 routing protocols. Now, just about every routing protocol has already gone in architecture updates so that it can run for IPv6. You can also use static routes for IPv6 as well. But you can see, for instance, RIP-NG, or next generation, that, by the way, is the common name for IPv6 is IPNG. So RIP is running the new version and able to handle that. And by the way, everything in RIP is the same, other than the multicast address that it's using to communicate with its neighbors. It's going to be the new flavor of multicast, the FF02::9, which is the same thing as 224.00 dot. Now all my IPs are blurring in my head. The old multicast address that RIP was using. You see OSPF has changed over from version 2 to version 3. EIGRP and ISIS are now for IPv6. BGP is the same, but now they've added multi-protocol extensions to it to allow it to support IPv6, among many other things. If you've gotten into MPLS at all, that is also one of the protocols that uses the multi-protocol BGP. Cisco wants you to know a little bit about OSPF, the new flavor. What's new in OSPF? And that's what we're going to configure between our two routers to allow the Ethernet interfaces to be learned and communicate. First off, OSPF version 3 has a smaller header. They've stripped out all authentication options from OSPF because IP version 6 has authentication. IP version 6 in the RFC is said to support IPsec everywhere, which IPsec does authentication. It also does encryption if you want that as well. So with that in place, we've kind of removed those functions from OSPF and just said, hey, the root protocol can do it, so why not use those? The second thing is no network statement. I put, hooray, it's awesome. OSPF is now enabled, just like ISIS, to where you go underneath the interface and say, this is the interface I want to run for OSPF. All neighbor communication is done through the link local addresses. So neighbors, obviously, will be on the same link. So they'll use link local addresses to communicate, and that thus separates the network that's being advertised from the interface that's being used to communicate. There's a definite distinction now. When your neighbors are communicating, you know that they're going to be using their link local addresses rather than one, or, remember, we can have many IPv6 addresses on our interfaces. Instead of trying to say, oh, no, use that one, no, that one, no, that one, we can just have it use the link local address by default, and that makes it so much easier. Multiple OSPF instances per link. This is a weird one, but it's doable. I put in odd network designs. You can actually run multiple flavors of OSPF, and when I say flavors, I mean like processes. You can go into global config mode and type in router OSPF, 1, 2, 3, 4, and have different processes running. So theoretically, you could assign a single network to multiple areas. Now that's a weird design, and when you get into when IP version 6 becomes more prevalent, I think we'll see a lot more options for those designs. I haven't really come up with a good use for that yet, but it's now supported. Number 5, new multicast addresses. Instead of 224.0.0.5 and 6, we now have FF02::5 and FF02::6. Those are going to be to the all OSPF routers as the 5, and then the DR and BDR as 6. And, oh, I doubled myself. No authentication. I mentioned that up top. The header is smaller because there is no authentication, and of course there's no authentication. Now that you've seen what's new, let's go ahead and set this up and get it running on our little mini network that we have here. Now, I want to mention a couple things have changed since I originally configured IPv6. I was doing a little, pre-game work, making sure that the OSPF would work correctly and testing some stuff out, and I found out that the routers that I was using did not support OSPF version 3, and according to the feature navigator on Cisco's website, it would never support OSPF version 3 because I was using 2610 routers, which were, a fairly popular router back in the day, and medium enterprise class router. But so what I did was I went ahead and swapped the routers out. Router 3 and router 4 will now be played by the part of a 1700 series router, which, when you think about it, makes much more sense that Cisco would release OSPF version 3 for a small home-based router than they would for the medium to enterprise class 2600 series routers. I'm not bitter that it took me a few hours to upgrade the iOS or swap those routers out and pull them out of the closet, but nonetheless, they are set up. So let's re-familiarize ourselves with this. Oh, the other thing I did, when we first set up IP version 6, I set up the Ethernet interfaces with a /16 mask, which, if you look at it, /32 is what it should be because this represents the network. By using a /16, I would just use that as the network, which would mean both that and that interface would be on the same network. That's impossible. So a /32 fixes that problem, and that's what I've assigned the addresses as. Let me just re-familiarize you with the new routers. I'm sitting on router 4, which is 1700 series router. Do a show IPv6 interface brief, and you can see fast Ethernet 0 now has the same IP version 6 address as before with the right mask, serial 0 set up there. Jump back out to, I have these sitting on a little pile on my desk rather than using a access server now, so I'll be switching my console cable. Show IPv6 interface brief, and that's what the view is as well. So you can see router 3 is configured exactly the same as it was. Let's get OSPF running. All I need to do is go on router 3 into global config mode, and the first command I need to type is IPv6 unicast routing. That is like the old IP routing command was for IP version 4, or like we saw in multicast, we had to type in IP multicast routing in order for that to work. IP version 6 routing isn't enabled by default, so we need to type that in. Then, after we type that command, we can type in this one, IPv6 router OSPF, and then our process ID. Just router OSPF will go into the old version, or version 2 of OSPF, which works for the IP version 4 protocol. This one will configure OSPF for version 3. So underneath here, I'll do a question mark, and you can see that there's not much action that takes place. And I think the big thing that should stand out to you is there is no network command. As I mentioned on those new features, the network command is removed. So what I'll do is just assign this a router ID. That's all I have to do, which has remained an IP version 4 style format because remember, this is just a name. It's not an actual IP address that this router uses to identify itself. So I'll give this the router ID 3.3.3.3. Exit back out. So OSPF is now configured on router 3, at least in the router sense. Those are the only two commands I have to do under the router config mode. All of the other commands, essentially the network command, has moved under the interfaces. So I'll do a quick show IP interface brief. Still like that command's view better than the new IP version 6 one. Let me go under interface fast Ethernet 0. It already has the IP address assigned, so all I need to do is type in this, IPv6 OSPF, followed by what process ID I want to assign to the interface. Now remember, I said on the new features that one of the things you could do is assign multiple processes to an interface, meaning that an interface could be in multiple areas. It'd be a weird design, but it can be done. So I used process 100, so I'll replicate that here. OSPF process 100, area 0. Fast Ethernet 0 is now active in OSPF. Go under interface serial 0, do the same command, done. So at this point, router 3 is set up and working for OSPF. Now, before we do the verification commands, let me jump over here to router 4 with my console cable. Click back down here. All right, I'm now back on router 4. I'll just go and set those same commands, IPv6 unicast routing. If you don't do that command and you type in IPv6 router OSPF, it will give you an error message. It will say you have to turn on unicast routing first. So as before, the only thing I'm going to do is set the router ID on this router. You're done in the router config mode. Interface fast Ethernet 0, and I will do a IPv6 OSPF area, oh, yeah, process 100, area 0. So I'm assigning that into area 0. Oh, and by the way, this is a feature that was in IP version 4, or the OSPF version 2, the later versions of it, supported an area ID in an IP address format. So you could kind of manage your areas a little better than just doing a flat number. But for now, I'll just stick with the old area style, area 0. I'll go under interface fast Ethernet 0 and also assign that, oh wait, serial 0. Also assign that to OSPF 100 area 0, and we are good to go. So at this point, both router 3 and router 4 are running OSPF and should be communicating at this point and advertising the Ethernet networks to each other. Let's check out the verification commands. I'll start on router 4 because that's where I'm already plugged into, and do just the base verification commands. I'll do show, and the beauty is this the same show commands as before, but with IPv6 in between. So instead of show IP OSPF, it's show IPv6 OSPF. And that will show me that I have OSPF version 3 process ID 100 running with this router ID. And it shows what interfaces or the number of interfaces I have slotted in the backbone area. I can see how often or the delay on the SPF algorithm. It's going to wait 5 seconds before it runs that for any changes, and that keeps the flapping interfaces from killing your router. Hold time between two SPF runs is 10 seconds, so 2 back-to-back runs. And I mean, these are just timers. We've seen a million timers before. So you can see just about everything about this OSPF process. Now, if I want to see my neighbor relationships, it's show IPv6 OSPF neighbor. And you can see that we have a neighbor relationship with router 3. It's a full relationship, same concepts before. If this was on an Ethernet segment, we'd have a DR, we'd have a BDR, similar style. We have interface serial 0 is what we've learned that neighbor on. We can also type in show neighbor detail, and we'll see that neighbor, oops, 3333 on serial 0. Oh, and look at this. link local address. Remember I said that is going to be what's used for the communication with the neighbor. It doesn't use the unique local or global IP addresses on the interface because it's only communicating between neighbors. So why would it use one of those addresses when it could cause confusion? Remember, our router can have many IP version 6 addresses on a given interface. We'd have to figure out, oh, which one do you use? Is it matching the other side? All that kind of stuff. So eliminate all that. The default is to use the link local address to talk to its neighbor. State is full. It shows 12 state changes that it's gone through already with this neighbor. Just, all the information about that neighbor. Trying to think what other commands. I know you're waiting for it. You want to see the routing table, but I think that's it. That's the main one. You can also do a show IPv6 OSPF interface, and you can check out the interface stats. And okay, let's do the show routing table. You've seen all this kind of stuff in IP version 4. So, oh, hey, there's still the network types. Remember those where we talked about the different styles of networks and the timers? All of that is the same in OSPF version 3. So you don't have to worry about relearning everything. You still have the point-to-point network style, broadcast, NBMA network styles, all the same. It's just we're just working in the IP version 6 world. So let's do it. Show IPv6 route to see the IP version 6 routing table. Look at that. The L's represent all of the link local addresses. We don't really need to worry about those. Here's our connected interfaces, and right there, oh, beautiful, is our IP version 6 OSPF route that has been learned. This is, from router 4's perspective, 1FE01111::32. Let's look at our diagram. You can see router 4 has 2222, and it learned about 1111 from router 3. So let's jump on over to router 3. So used to my Control-Shift-6X. Oh, dropping cables. I'm telling you, this is all Cisco's fault. No OSPF image for the 2610. So back here, I'm going to do a show IPv6 route. I bet you they're going to come out with one. They just haven't yet. There it is. That's the, oh my goodness. I think I forgot to change that mask. I must have forgotten to change the mask on the interface of router 4 because you can see it's still learning a /16. Now, I guess the good news is it's not going to cause any problems. It's a horrible design. That is unacceptable. You should never have that happening. But it's not going to cause any issues because the routing process uses the same rules for routing that it did in IP version 4. So it's going to use the most specific route. It will route to 1111 out its connected interface with that /32 because it's a more specific route than the OSPF route. Any other 1FE0 route will be sent to the neighbor over there. Again, horrible design. I will immediately go and fix that as soon as this demonstration is done. But you can see that either way, the route was learned through OSPF over the link. So that is how you configure OSPF version 3. In my opinion, once you get used to the commands, much more simplified than the IP version 4 version because there is no more network command. All right, the last thing what we'll talk about that deals with IP version 6 is the migration strategies. This is, I would say, the best news ever about moving to IP version 6. The technology is out there that allows you to run IP version 4 for nearly as long as you'd like inside of your network. There is a non-pressurized approach that you can take to transition over. The first one that you can see on the list is dual stack routers. That's where you have a design like this. You have a router, just like we saw in the demonstrations I was doing, where the router itself has dual protocol stacks. It has IP version 4 addresses assigned to an interface and IP version 6 addresses assigned to an interface to service each one of those clients that you have on the network. So if you choose this strategy, what you could do is have a connection on that router to an IP version 4 flavor of the internet, which service providers will be providing for quite some time to come until, essentially right now, the internet is IP version 4. And there's this tiny subset of the internet that is IP version 6. Some people called it the 6 bone, but that name is now outdated because it's grown much bigger than the 6 bone originally was. So as of right now, major IP version 4 internet, tiny IP version 6 flavor. But the people that are connecting to the IP version 6 internet have transition strategies that allow them to reach the IP version 4 internet, some of which we'll talk about in just a moment. That, you know, if you connect to this one, you're able to get over to the sites on the old one. And if you connect to this one, you can reach over to the sites on the new one. So, with that in mind, you could have an ISP that provides you dual connections, one to the version 4, one to the version 6. As you migrate your clients over here, you can have the version 6 clients, you know, have a route map or be in a separate VLAN or whatever the case may be to route them out to the IP version 6 flavor of the internet, and the 4 clients route this way to the version 4 of the internet until eventually everybody moves over to the version 6 internet, and voila, you're done. Now you can sever your connection to the IP version 4 internet. You can remove all IP version 4 addresses from your routers. Everything is put in place to use full IP version 6. That is one transition strategy. The second transition strategy is tunneling. Tunneling allows you to tunnel your networks through whatever style internet you want to. Let me explain that a little more. Let's say you're running IP version 4 inside of your networks. You can have a version 4 address assigned to your interface right here and right here. Maybe these are your offices. Assign an IP version 6 address to the outside interface, and then create a tunnel. Just a straight tunnel interface. If you have ever created one of those, they're a piece of cake. You just go in, type in interface tunnel and a number, and you'll create this tunnel interface that allows you to create essentially a VPN style connection through the IP version 6 internet that keeps you using IP version 4 between your offices and yet able to access the version 6 internet. Now this is down the road, maybe when there is no, or I should say, the IP version 4 internet is much smaller than it is today, where it's the major one out there. And you would probably combine that strategy with the last one on the screen because, you know, your offices can access each other, but unless you employ some other strategy, the offices won't be able to access the IP version 6 internet. So that is where NAT PT comes in. NAT PT is the new flavor of NAT. It's called NAT Protocol Translation. What it does is do NAT, just like we've come to know and love, but between IP version 6 clients and the IP version 4 internet, or vice versa. IP version 4 clients to an IP version 6 internet. It works exactly the same as NAT. It's just when you do a show IP NAT translations to see the table. As a matter of fact, hang on. Let me do an on-the-fly view of that. I'm connecting over here to my my production router that allows me to access the internet. And I'll do a re-authentication because I typed it wrong. And I'll do a show IP NAT translations. And you can see that I have all these translations, the inside global, inside local, outside, you know, all of these IP addresses that are being translated to the different sites that my devices are going to. In the NAT PT, what you'll see is instead of IP version 4 addresses everywhere, you'll see some that are version 4 on maybe the outside that you're translating to, and some that are version 6 on the inside that you're translating from. Now, I'm mixing up the local and the global, and if you know about NAT and all these terms, I'm not going to get into that. You'll have a mix of version 4 and version 6 addresses in this table because it will actually translate from one protocol to the other. I don't know if you noticed it. Let me find my connection here to the IP version 6 router I'm running. But when I typed in IPv6 question mark in global config mode, one of the things that you wouldn't have noticed because it's not there is that hang on, let me grab my production router. This is a 2801, so it's got a little newer iOS. Are you seeing this anywhere? I'm not seeing it. I know it's there somewhere. But the point is that somewhere on this router is a command. Hang on, and now it's going to drive me nuts. But somewhere is a command that does NAT PT. It is a NAT protocol translation that will allow you to translate from version 6 to version 4. It's the new flavor of NAT. Okay, just so I can prove that I'm not crazy, I went to Cisco website, just did the search for configuring NAT-PT, and you can see that in global config mode, you just type in IPv6 NAT, and that's where your commands exist. So obviously my router platforms just don't have a new enough version of the iOS to have NAT-PT on there. Oh, okay, I'm relieved. So what we did talk about was assigning, we went through configuring, routing, and interoperating with IP version 6 and IP version 4. We first saw the configuration of assigning IPv6 addresses to your router, which is the same exact thing as assigning an IP version 4 address. We just have v6 in there and the address is quite a bit longer. We looked at what's new with the new routing protocols and then went through a configuration of OSPF version 3. Now do remember that is the base configuration. We didn't get into summarization and all of that. As IP version 6 becomes more prevalent, you can guarantee that Cisco is going to keep adding more and more of it to the certification track, more and more of it to their iOS support. But as of right now, I mean, to get IP version 6 stuff, you're looking at latest and greatest iOS versions that you are upgrading to in order to handle that. Finally, we saw IP version 4 to IP version 6 migration strategies. The three methods: dual stack, tunneling, and then also going in there and using NAT-PT on new routers to do NAT between IPv4 and 6 networks or vice versa. I hope this has been informative for you, and I'd like to thank you for viewing.